We'll continue doing some more problems. So try and solve this question. In AM, peak amplitude of carrier before modulation and after modulation are given by. Yeah, before modulation, carrier signal C of t is AC cos 2 pi f ct. And after modulation, the modulated signal is AC into 1 plus Ka m of t of cos 2 pi f ct. So before modulation, amplitude of the carrier signal is AC. After modulation, it is AC into 1 plus Ka m of t. Therefore, option C is the answer. Let's try and solve this. What is the answer? Yeah, we'll just check on that. In an A modulating system, carrier amplitude of 10 volt, carrier power AC square by 2R. R is not given, so you can take it as 1 is 50 watt. Antenna resistance, the second question is given as 10 ohm. Then the carrier power is 5 watt. So option C is the answer. Next, try to solve this. In an AM modulating system, carrier amplitude of 1 volt, antenna resistance of 1 ohm, modulation index is kept at max, that is 1. Find carrier power AC square by 2R, it's 0.5 watt. Sideband power PC into mu square by 2, that's 0.25 watt. Total power, carrier power plus sideband power, 0.75 watt. This is one way. Another way where you must get the same answer is sideband power is AC square mu square by 4R, should also give you the same answer. Total power is PC into 1 plus mu square by 2. That's 1 by 2 into 1 plus 1 by 2. Should also give you the same answer, of course. So 0.5, 0.25, and 0.75 watt. Option D is answer. Yeah. Let's try to solve this. Keep solving. Meanwhile, you keep solving. Just give me a moment, okay? Please solve this meanwhile. Okay, what's the answer? Did you got the answer? Okay. Option B. Hmm? Shall we? Okay, we'll try to analyze. What is your answer? Type again. Okay. You're saying option B. Okay. Okay. Option B is nothing but identify the true statements. 1 and 2 are true, you are saying. Hmm? We'll see. Identify the true statements. In AM system, maximum sideband power is 33.33%. For example, if you take an AM system, sideband power percentage eta is mu square by 2 plus mu square. When mu is equal to 1, you get the maximum value. Percentage eta is 1 by 3 into 100. Maximum is 33.3%. Why I'm saying this? Because, for example, if mu is 1 by root 2, anyways, mu cannot be greater than 1. In an AM system, you cannot go beyond 1. For example, mu is 1 by root 2, that is 0.707. Then see what happens now. Percentage eta is mu square, 1 by root 2 whole square, 1 by 2. That's 0.5 by 2.5 into 100. That's 1 by 5 into 100. That's 20%. Clearly less than 33.3%. So it cannot go beyond 33.3. Still, if you decrease to around 0.5, it is 1 here, decrease to 0.707, decrease to 0.5. Then percentage eta is 0.25 by 2.25. That's 1 by 9 into 100 will be 11.11%, still decreased. Now you can see there is a decline in the value. So I can say the maximum value is 33.3%. So this is definitely true. How about the second statement? Now, if you see carefully, total power is carrier power plus sideband power. You know, eta is sideband power by total power. So if you analyze, let me write it here. When mu is equal to 1, eta, which is sideband power by total power, is 33.3%, implies sideband power is 33.3% of total power. Similarly, when mu is 1 by root 2, eta, sideband power by total power, but it has 20%, implies sideband power is 20% of total power. Similarly, when mu is 1 by 2, eta, sideband power by total power is 11.11%, implies sideband power is 11.11% of total power. Now, if you substitute for mu is equal to 1, total power is carrier power plus sideband power, which is 33.33% of your total power, or 0.33 of PT. Now, if you want to make 1 PT, this is 66.67% of total power. So from this, we got when mu is equal to 1, carrier power is 66.67% of total power. When mu is 1 by root 2, total power is, this is 20% of total power. So this will become 80% of total power. So when mu is 1 by root 2, carrier power is 80% of total power. Similarly, when mu is 1 by 2, this is sideband power is 11.11% of total power. This will become 88.89% of total power. Therefore, when mu is 1 by 2, carrier power is 88.89% of total power. Got it? Now clearly, you can see the carrier power is rising. The minimum carrier power is 66.67%. Now you read, in an AM system, maximum carrier power is 66.7%. Is it the maximum or the minimum? Sadly, that's the minimum. That's the confusion generally happens. So this is false. This is false. Is this clear what I'm trying to say? Okay. Yeah. So that's a general confusion. So this is not max, but rather this is min. Minimum carrier power is 66.7. Next, third statement. Is it true? So what's the answer? Okay, tell me what's the answer now. Option A. Why option A? What about the third statement? In an AM system, when the modulation index is changed from 1 to 0.707, modulation index is changed from 1 to 0.707, sideband power decreases from 33.3% to 20%. That's correct only, no? Why it is wrong? It increases. Why it increases? Sideband power, no? When I move from mu is equal to 1 to mu is equal to 0.707, at mu is 1, it is 33.3%. At mu is 1 by root 2, it is 20%. Yeah. Yeah. Correct. It decreases by 20% is wrong. Decreases to 20%. Correct. Or decreases, if you want to use decreases by, then it decreases by 13.33%. Because from 33.3% it went down to 20, it decreased by 13.33. So there is a small trick in the statement. So this is also false. Only A. A option A, only one is true. Clear? Yeah. Next. Try to solve this. Oh, what's the answer? In an AM system, mu is equal to 1. Sideband power is 100 watts. Find the total power. Total power is carrier power plus sideband power. Sideband power is PC into mu square by 2. So sideband power is given as 100 watts. 100 is PC into 1 by 2, mu is 1. So carrier power is 200 watt. Total power is carrier power plus sideband power. 200 plus 100. Total power is 300 watt. Given total power is 200. This 200 is not total power, but the carrier power actually. This is false. When mu is decreased to 0.707, it was 1. Now it is decreased to 0.707. From mu is equal to 1, we decrease to mu is 0.707. The sideband power and carrier power of the ratio 80 and 20. When I move from mu is 1 to mu is 0.707, for mu is equal to 0.707, for mu is equal to 0.707, this case, carrier power is 80%, sideband power is 20%. This is correct, no? Why this is wrong? Why this is wrong? Anyone? Can anyone tell me why that question is wrong? Bhumika? Can anyone tell me why that is wrong then? Yes, correct. The statement is marked reversely. The sideband power and carrier power. It should be 2080 then. It is reversed. That's why it is false. Numbers are okay, but they're reverse. Option D is the answer. Yeah, find this. Anyone got the answer? Yeah. In an AM system, initially mu is at 0, then mu is changed to 1. Then the percentage increase in total power is, so when mu is 0, PT is equal to PC into 1 plus mu square by 2. When mu is 0, PT is equal to PC. Now, mu is changed from 0 to 1. PT is equal to PC into 1 plus mu square by 2. That is 1.5 PC. So now it increased by 50%. Because this is 1 PC plus 0.5 PC. It increased by 50%. Mu is 1 by 2. PT is equal to PC into 1 plus mu square by 2. PT is equal to PC into 1 plus 1 by 8. One 1.125 PC increases by 12.5%. Mu is 1 by root 2. PT is equal to PC into 1 plus mu square by 2. PT is equal to PC into 1 plus 1 by 4. 1.25 PC. That's 25%. Okay. So 50, 12.5 and 25. Option B is the answer. Now, for example, mu is operating at maximum. For example, mu is operating at maximum and mu is increased by 100%. Okay. Mu is operating at maximum and mu is increased by 100%. Then PT increases by, PT changes by dash percent. What's the answer for this? Think. Mu is operating at maximum and mu is increased by 100%. What is the change in PT? Calculate PT here, calculate PT here, and tell me the change. Yeah, absolutely correct. When mu is operating at maximum, mu is 1, PT is 1.5 PC. If mu increases by 100%, that means mu became 2. Now, PC into 1 plus mu square 4 by 2, that's 2. Become 3 PC. 1.5 PC became 3 PC. Improvement 8%. Final value minus initial value by initial value into 100. Improvement is 100%. Of course, you might have known this, no? Okay. Why I'm saying this? Because sometimes it is not so easy to tell this direct. Then you use this formula. Final value minus initial value by initial value into 100. Is this clear? It is very obviously clear here. The values are 1.5 PC to 3 PC, 100% improvement. That's okay. But there may be some situation where you cannot directly tell like this. Then better to rely on a formula. Final value minus initial value by initial value into 100 will give you the percentage change. Or I can say the percentage increase. Everyone, is that clear? Any doubts? Anyone? Any doubt? Is that clear, the procedure? Okay. Shall we go for the next question then? Solve this. What's the answer? Okay. In an AM system, Vmax is given by 20 volt. Vmin is given by 10 volt. AC is the average of Vmax and Vmin, which is 15 volt. Find mu. Mu is Vmax minus Vmin by Vmax plus Vmin. It's 10 by 30, 1 by 3, 0.333. 15 and 0.333. Option C is the answer. In an AM system, before modulation, the current is 10 amp. When mu is equal to 1, the current is. Please do it. Very good. In an AM system, before modulation, current is 10 amp. Mu is 0. No modulation. When mu is 1, the current is IT, IC into under root of 1 plus mu square by 2. IC is 10 under root of 1 plus 1 by 2. 10 root 3 by root 2, which is correct. 10 can be written as 5 into root 2 into root 2. That's 5 root 6 is correct. Root 3 can be written as 1.732 into 10. 17.32 by root 2. This is also correct. 17.32 by 1.414 is 12.24. So this is also correct. Option D is the answer. The trick here is you should read the complete question. Otherwise, you'll end up here. And you see the first option, which looks pretty okay because this is correct. And naturally, you'll not care about the rest of the things generally. So you may land here sometimes. So reading all the options is always a good thing to do. Okay. Yeah. Calculate this. Type your answer in the chat box. Okay. Okay. Uh, D. Okay, we'll check. Okay. Okay. We'll check. We'll check. In an AM system, S of t is given as 10 into 1 plus zero point 0.8 times cos 2 pi into 10 power 40 cos 2 pi into 10 power 60. Now, this is of the form AM singleton modulation. S of t is equal to AC into 1 plus mu times cos 2 pi FMT times cos 2 pi FCT. If you compare, AC is 10 volt, mu is 0.8, FM is 10 power 4 hertz or 10 kilohertz, FC is 10 power 6 hertz, 1 megahertz. It asks us to find PC. PC is AC square by 2R. We know when R is not given, by default it is 1 ohm. 100 by 2, that's 50 watt for you. Next, eta, mu square by 2 plus mu square. Mu is 0.8 here. So 0.64 by 2.64 into 100. This will be 24.24%. Next is bandwidth. Bandwidth of AM is 2 FM. FM is 10 kilohertz. So bandwidth is 20 kilohertz. Next is Vmax. Vmax is AC into 1 plus mu. 10 into 1 plus zero point 0.8. That's 18 volts. So all the options are true for D. Option D is the answer. Therefore, option D is the answer. Okay. Next one. Okay, solve this. This is from multitone modulation. Yeah, this is from multitone modulation. What is the answer? C. Okay. Okay. We'll check once. In an AM system, given AC is 10 volts, mu1 is 0.3, mu2 is 0.4. Find carrier power AC square by 2R. R is not given, so 1. So this is 50 watts. Next, mu t. Mu t square is mu1 square plus mu2 square. Mu2 mu t square is 0.3 whole square plus 0.4 whole square. 0.09 plus 0.16. 0.25. Mu t is 0.5. Obviously, once this is done, this should be the answer from the options. Anyways, we'll find the other also. PT is PC into 1 plus mu t square by 2. 50 into 1 plus 0.25 is 1 by 4 by 2 is 1 by 8. So this is 56.25. Eta is mu t square by 2 plus mu t square. 1 by 4 by 2 plus 1 by 4. 0.25 by 2.25, 1 by 9. 1 by 9. Option C is the answer. Yeah. Try and solve this. He is asking us to find the maximum modulation efficiency. Modulation efficiency will be maximum when mu is 1. So for sinusoidal input, eta mu square by 2 plus mu square into 100. That's 1 by 3 into 100. 33.3%. Rectangular input eta mu square by 1 plus mu square into 100. 1 by 2 into 100. 50%. Triangular input eta mu square by 3 plus mu square into 100. That's 1 by 4 into 100. That's 25%. 33.3, 50, and 25. I'm getting D. What you said, answer? Yeah. Was it also D? Someone gave me answer already. D. Yeah, correct. Next question. Next question. In a time system, AC is 20 volts, mu is 0.5, find dt. PT is PC into 1 plus mu square by 2 for sinusoidal input. So let me find PC first. PC is AC square by 2R. That's 400 by 2. R is not given, 1 ohm. That's 200 watt. PC is 200 watt. 200. 1 plus mu is 0.5, 1 by 2, 1 by 2 whole square, 1 by 4, 1 by 8. That's 225 watts. Either B or C. Rectangular input PT is PC into 1 plus mu square. 200 into 1 plus 1 by 4. That's 250 watt. So it must be B then. Because that's the only option which is matching. For rectangular input, we are done. For triangular input, PT is equal to PC into 1 plus mu square by 3. 200 into 1 plus 1 by 3. Okay, that's 1 by 2. Yeah. 1 plus 1 by 12. Approximately 216. Option B is the answer. Option B is the answer. Yeah, correct. Next question. Yeah. What is the answer for this? Yeah. Sorry, somehow I got disconnected. Okay, let me share the screen. Okay, I should on it. Okay. Okay, fine. Sorry, somehow system got stuck. Is audio video clear? Yeah, thank you. So in an AM system, which is using a square law modulator, you know how a square law modulator looks like. You have a message signal, you have an adder to which you give the carrier signal. Input sum of this two, let it be V1 given to a nonlinear system, it gives you V2, where V2 is A V1 plus B V1 square. It is passed through a band pass filter. This is a square law modulator. So what is given in an AM system using square law modulator, the input to NLS is a sum of message and carrier signal. Absolutely true. True. Using square law modulator, the output of NLS is fed to band pass filter. Yes, output is fed to band pass filter. That's also true. Using square law modulator, the output of NLS is fed to low pass filter. No. Using square law modulator, the input to NLS is the difference of the message and carrier signal. This also no. 1 and 2. Option A is the answer. Next question. Try and solve this. What's the answer? B. Let us check once. Yeah. In an AM system with a carrier amplitude of 10 volt, AC is 10 volt, radiated across a 100 ohm antenna, modulation index of 0.5, carrier power is AC square by 2R, 100 by 200, 0.5 watt. So it must be between A and B. And options are very easy because the rest are same. Only last one is changing. So let us calculate that. Eta mu square by 2 plus mu square 0.25 by 2.25, 1 by 9 into 100, 11.11%. Option B must be your answer. But how to calculate the other? Sideband power PC into mu square by 2. This is 0.5 into mu square by 2. Mu is 1 by 2. Mu square 1 by 4 by 2, 1 by 8. 1 by 2 into 1 by 8. 1 by 16. 0.0625. That sideband power. Total power is 0.5 plus 0.0625. It's 0.5625. Therefore, option B is the answer. Next. Try to solve this. Yeah. In an AM system, AC is 10 volt, mu is 0.707, 1 by root 2. The total power radiated PC into 1 plus mu square by 2 for sinusoidal input. So PC is AC square by 2R. That's 50 watt. It's 50 into 1 plus mu is 1 by root 2. So 1 by 2 by 2, 1 by 4. This is 62.5 watts. Next, for triangular input, PC into 1 plus mu square by 3, 50 into 1 plus 1 by 6. That's 58.33 watt. Triangular input. For rectangular input, PT is PC into 1 plus mu square. 50 into 1 plus 1 by 2. 75 watt. 62.5, 58.33 and 75 watt. Option D is the answer. Next, find this. See, that's very quite simple because given mu is equal to 1 by root 2 on the modulation efficiency, triangular input is mu square by 3 plus mu square, 0.5 by 3.5. That's 1 by 7. Eta for sinusoidal input is mu square by 2 plus mu square, 0.5 by 2.5. That's 1 by 5 for sinusoidal input. Eta is mu square by 1 plus mu square, 0.5 by 1.5. That's 1 by 3 for rectangular input. 1 by 7, 1 by 5, 1 by 3. Option B is the answer. Hmm. Next one. Find the answer. In an AM system, When mu is changed from minimum to maximum, that is from 0 to 1, at maximum, that is at 1, for sinusoidal input, value of eta is mu square by 2 plus mu square for sinusoidal input. When mu is 1, that's 1 by 3. I want in percentage, 33.33%. So this is 33.33%. If mu is decreased to 1 by root 2, the value of eta is mu square by 2 plus mu square, 0.5 by 2.5. That's 1 by 5 into 100. That's 20%. Eta is 20%. What is the percentage change in eta? From 33.33, it has decreased to 20. So percentage change is 13.33%. When mu is equal to 1 by root 2, the input is changed to dash to achieve the value of eta as in 1. If I want to achieve 33.33%, I must change the input from sinusoidal to what? I'll change it to rectangular so that eta is now mu square by 1 plus mu square. Mu is 1 by root 2, 0.5 by 1.5. That's 1 by 3 into 100. You'll get back again 33.33%. So the input must be changed to rectangular input to get the same answer. Okay, therefore, option B is answer. Anyways, the options are very easy here. By the time you get this first answer, your answer is done. So, most likely, if you see the options, then it is easy. If the options are difficult, then that's a very good question actually. A weaker option will make a difficult question easy for us actually. So you should also check out the options when you're dealing with problems. Okay. In an AM system, Vmax equal to 25 volt, Vmin is 5 volt, AC Vmax plus Vmin by 2, that's 15 volt. Mu is Vmax minus Vmin by Vmax plus Vmin, 20 by 30.667. 59.667. The approximate one is this. Okay. Option B is answer. Solve this. Yeah, what's the answer? In an AM system, antenna current is 10 amp before modulation and 12 amp after modulation. Determine mu. IT is equal to IC into under root of 1 plus mu square by 2. 12 is 10 into under root of 1 plus mu square by 2. 1.2 is under root of 1 plus mu square by 2. 1.44 is 1 plus mu square by 2. 0.44 is mu square by 2. Mu square is 0.88. Mu is under root of 0.88, which is 0.938. Now, eta input is not mentioned. So by default, it is sinusoidal input. Mu square by 2 plus mu square. 0.88 by 2.88. 0.305. 30.5%. Option C is answer. Okay. So multi-tone modulation. Solve this. What is the answer? In an AM system, AC is equal to 10 volt. R is 15 ohm. Mu1 is 0.6, mu2 is 0.7. Okay. Then find PC. PC is AC square by 2R. That's 100 by 30. 3.333 watt. Either this or this. Rest are same. Can find eta. Mu square by 2 plus mu square. Mu square is mu1 square plus mu2 square. 0.36 plus 0.49. That's 0.85. 0.85 by 2.85 into 100, 29.81%. So this will be the answer. Similarly, you can find the sideband power. PC into mu t square by 2. 3.333 into 0.85 by 2. 1.416. When you add up now, 4.749. So option A is answer. A square law modulator has NLS with response V out is equal to 2 V in plus 0.2 V in square. If the message signal amplitude is 10 volt, then find Ka and mu. Solve this. Find Ka and mu. How to find Ka? Ka is 2B by A. Here, V out is AV in plus BV in square. From this, A is 2, B is 0.2, Ka is 2B by A, 2 into 0.2 by 2. So Ka is 0.2. Mu is Ka into Am, 0.2 into 10. Mu is 2. 0.2 and 2. Option B is answer. Let's solve this. In an AM system, the response of an NLS of a square law modulator is find Ka. Ka is 2B by A. From this, A is 0.1, B is 1, 2 into 1 by 0.1. Ka is 20. And also find mu. Mu is Ka into Am. And from this, Am is 0.05. Mu is 1. 20 and 1. Option A is the answer. Is that clear? Let us solve this now. 10 signals, each band limited to 5 kilohertz. Band limited to 5 kilohertz means its bandwidth is 5 kilohertz. Its bandwidth is 5 kilohertz means signal is in this way. This is FL, this is FH. Because in bandwidth calculation, you will not consider negative frequencies. So when he's saying 10 signals, each band limited to 5 kilohertz, means bandwidth is 5 kilohertz. Means here FM is 5 kilohertz automatically. Highest modulating frequency is 5 kilohertz. So whenever you see this term, each band limited to 5 kilohertz, band limited to X kilohertz, that value will become FM automatically, the highest modulating frequency. Are transmitted through a channel after modulation using FDM. Guard band is 2 kilohertz. Determine the bandwidth of the multiplexed signal if all the modulators are AM. If all the modulators are AM, first AM modulator, AM takes total of 2 FM. The important thing in this question is understanding that FM is 5 kilohertz. If you fail in doing so, then your complete problem will go wrong. So whenever you see this term, each band limited or band limited to, means band limited means this picture should be visualized by you. Once you visualize this picture, you understand that FM is this value. Once you understand that, each AM channel takes a bandwidth of 2 FM. Now things will become easy. It will take 10 kilohertz. This channel will take 10 kilohertz, followed by a guard band of 2 kilohertz. Next channel, 10, 2, 10, 2, it follows. Now tell me, if there are 10 signals to be modulated, what is the total bandwidth required? Please type your answer. What is the answer? Each AM channel takes 10 kilohertz. Such 10 signals are there. 10 into 10, 100 kilohertz. Plus, for 10 channels, you have only 9 guard bands. That is the important thing that you should understand. Here, for 3, you have 2 guard bands. For 2, you have 1 guard band. For 10, you have 9 guard bands, but not 10. That is what you should remember. 9 into 2 is 18. Total is 118 kilohertz. If all the modulators are AM, then it takes a bandwidth of 118 kilohertz. If all the modulators are DSB, you know DSB and AM take same bandwidth of 2 FM that we discussed in the theory in the previous class. So this will also be 118 kilohertz. Now if you replace all of them with SSB, for example, you are considering the upper side band, this will be only 5 kilohertz. Followed by guard band of 2 kilohertz, then again 5 kilohertz, guard band of 2 kilohertz, 5 kilohertz, so on. So this will become 5 into 10, 50. Plus guard band, remember, will not change. 9 guard bands will be there, each of 2 kilohertz. This will remain the same, 18. So total will become 68 kilohertz. Is that clear? Okay, with this we'll conclude. Thank you all. Have a great day.